Hello friends, welcome to CBSE Standards. I am Loknath going to teach about carbon and its compounds. Chapter number 4, class 10. It is one of the very important chapter as far as your chemistry is concerned in class 10. For your exam point of view, it is very important part to see what are carbons. We know that friends, carbon is one of the non-metallic elements which is found in the periodic table having a group number 14 and periodic number 2. That means the address in the periodic table is that it is in the group number 14 and periodic number 2 in the periodic table. And carbon is a non-metallic element. That is the important part. You have to remember that carbon is a non-metallic element found in the periodic table. Let us have a look. Metallic element found in the periodic table having its period number 2 and group number 14. It is the address of carbon in the periodic table. Is it right? Where we can find the carbon in the periodic table? If we will go to the period number 2 and group number 14, then we will find the carbon, the element carbon, which is a non-metal. Is it right? We know that. Let us come to see the carbon. What is atomic number of carbon is, you know, it is 6. Atomic number of carbon is 6. That is Z is equal to 6. Is it right? If we will distribute the electrons in different cell, we will find that the first cell will occupy 2 and the second cell will occupy 4. That means carbon has 4 electrons in its outermost cell. Is it right? Carbon has 4 electrons in its outermost cell. And what? So it is called what? Tetravalent. Why? Because if you calculate the valency of carbon, you will see that 8 minus 4, you are getting what? 4. You are getting 4. Number 1. So it forms covalent bond with the other atoms or elements. Because why? Because you see the carbon has 4 electrons in its outermost cell. There are 4 electrons in its outermost cell, and if carbon will donate 4 electrons in order to gain the satisfy the what? Carbon 4 plus, it is very difficult in the part of carbon, because in this process huge amount of energy will be lost or spent, so it cannot do such process. And then it will neither accept 4 electrons, it will also neither accept any 4 electrons from others, forming carbon anions, that means negative ions. This is your, you see, this is your cation or positive ion, this is your anion or negative ions. So what we got from this statement is that carbon has 4 electrons in its outermost cell, so it is neither donates nor receive or gain electrons from others in order to satisfy its octet rule. In order to satisfy the octet rule, or octet configuration, we can say octet. So that means that the octet rule is satisfied. We know that the inert gases like helium, neon, argon, krypton, xenon, radon. So these 1, 2, 3, 4, 5, 6. These are 4 noble gases or inert gases. They have, except helium, which has 2 electrons in its outermost cell. Every atom has 8 electrons in their outermost cell. So they are most stable. So they are inert. They are stable. So do not form compounds bonds with others. That is, so every atom try to or want to satisfy this octet rule. Having 8 electrons in their outermost cell in order to acquire stable configuration is called the octet rule. Is it right? In order to gain, this is the every atom tries to keep its outermost full. That is 8 electrons, except helium. Though helium has 2 electrons in its outermost shell, still then it is satisfying its octet configuration. Is it right? This one, number 1. So why, question may come, why carbon forms covalent bonds instead of electron valent or ionic bonds? The simple answer is that carbon has 4 electrons in its outermost shell, so it is very difficult to lose 4 electrons in order to become carbon 4 plus, or it is also same time very difficult to gain 4 electrons in order to become what, carbon 4 minus. Is it right? So it neither donates it nor receives any electrons from others, but it shares and pairs the electrons. That's why the bond which is formed by the sharing pair of electrons is called covalent bonds. That is why carbon forms the covalent bond instead of ionic or electrovalent bond. Is it right? So this is the some simple introduction or idea about this carbon. Now let us see the sources of carbon. Sources of carbon. Where we can find the carbon? Sources of carbon. Friends, carbon is found everywhere. It is omnipresent. You can say in the air. You must have seen the carbon dioxide gas. You can say the Earth's crust. Earth's crust, you can say. That may be ocean crust, that may be solid or terrestrial crust. Earth crust is also present. It is present in the fossil fuels. Fossil fuels like coal, petrol, diesel, kerosene, etc. So all these are fossil fuels, and carbon is the most important composition of these fossil fuels. It's because these are organic compounds, and it is also found in the organisms, लिविंग ऑर्गेनिजम्स में कंपोजिशन है. जो ऑर्गेनिक कंपाउंड्स होते हैं, जो लिविंग बायोमोलिक्यूल्स होते हैं, जो लिविंग कंपाउंड्स होते हैं, एंड दैट इन द लिविंग ऑर्गेनिज्म दे आर आल्सो कार्बन प्लेज एन इम्पोर्टेंट रोल इन दिस कंपाउंड्स. सो इट इज आल्सो प्रेजेंट इन द organism. Next, it is also present in the papers or polymers, or it is also present in plastics. So everywhere these are also content you can say it the clothing materials, they are also carbon present, carbon is present. So these are the sources of carbon. Is it right? These are called the sources of carbon. एयर में कार्बन प्रेजेंट है, अर्थ क्रस्ट में प्रेजेंट, फॉसिल फ्यूल में कोल, पेट्रोल, डीजल, केरोसिन में प्रेजेंट, ऑर्गेनिज्म में प्रेजेंट, जैसे हम बोलते हैं द ऑर्गेनिक कंपाउंड्स में प्रेजेंट, जैसे हम बोलते हैं विनेगर बोलो, कुछ एसिड बोलो, एसिटिक एसिड बोलो, दीज आर ऑल्सो कार्बन कंपाउंड्स. कार्बन इज प्रेजेंट देयर एंड पेपर्स प्रेजेंट, क्लॉथिंग मटेरियल में प्रेजेंट. सो दीज आर द सोर्सेस ऑफ कार्बन. इज इट राइट? नाउ लेट अस सी द versatile nature of carbon. Versatile nature of carbon. Versatile nature of carbon. Versatile nature. What are the versatile? Unique features. Unique features. Unique features. Unique characteristics. You can say unique characteristics of carbon. Why carbon is rare than any other elements in the periodic table? Is it right? Why carbon is rare? Is it right? So let us see why. Number one, the versatile nature of carbon is that, number one, it is tetravalent. It's tetravalent means its valence is tetravalence. Number one, because it forms what shares pairs 4 electrons in other elements or atoms, forming its covalent bond. Covalent bond. Is it right? Number one, tetravalence is there. Catenation property. The most important property is that carbon to carbon, they can bond itself, forming a long chain. Carbon to carbon bond. It is a unique feature. Other than this carbon to carbon formation, carbon to carbon bond. By this way they can form long chains. This chain formation property of carbon is called catenation. Question may ask, what is catenation property of carbon? Catenation property of carbon is that carbon can form long chains with the carbon-carbon to linkage. Carbon to carbon linkage, carbon can form long. This is called self-linking process. Self-linking property. Is it right? Carbon can form, be clear here. Carbon combines with itself, forming long chain of carbon. This property of carbon forming long chain by self-linking with each other is called catenation property. Is it right? So next question, carbon forms number 3 is that it forms multiple bonds. Due to its smallest size. Carbon form the number 1 feature. What are the versatile nature? Number 1 feature, number 2 feature, number 3 feature. These are 3 important purposes, but that's why carbon is called versatile. And these are the nature, that's why carbon is called versatile nature of carbon. The unique feature, the unique property of what? Carbon. Is it right? So this last one is that carbon has a large tendency to form multiple bonds. That means double bonds or triple bonds. With the other atoms. So this forming, due to smallest in size, carbon forms multiple bonds with the other atoms. This property of carbon forming multiple atoms, it may be carbon, it may be oxygen, or it may be nitrogen, but it forms the multiple bonds. Due to formation of these multiple bonds, it gives it a versatile characteristic or nature, that is unique characteristic features of the carbon. So if question will come, what are the versatile nature of carbon, then what are the versatile nature of carbon, you will write these 3 points. Number 1, it is a tetravalent in nature, having 4 electrons in its outermost shell. So number 1, it is your tetravalent. Number 2 is that it is carbon to carbon chain formation, that is catenation. It can form long chains by carbon-carbon self-linkage, that is number 2. And number 3 is that it forms multiple bonds with the other atoms because of its strong tendency to form multiple bonds or smallest in size. Is it right? So this is what versatile nature of carbon. Is it? Next come to allotropes of carbon. Next is your allotropes of carbon. So what are the allotropes? Elements or atoms having similar chemical properties, but different physical properties. Quiet properties, different physical properties. Why different physical properties? Because of arrangement of atoms, in different way, in different structures. Okay, carbon, due to arrangement of atoms in different pattern, different structure, the physical properties of what elements varies, but chemical properties remain constant. If you will talk about carbon, you see, if you will talk about carbon, so carbon you can say other graphite, you can say it is a carbon compound, carbon material. You can say diamond, it is from carbon. You can say fullerene. So these are the allotropes of carbon: graphite, diamond, and fullerene. These structures arise from this carbon due to arrangement of atoms arrangement of atoms in different structures. Is it right? And there these allotropes are of two types. Two types you can say. Allotropes of carbons are two types. Allotropes of carbon are two types. One is your crystalline, a microcrystalline, जो बोलते smaller crystalline, smaller or microcrystalline features. In this case, diamond, graphite, fullerene. Diamond, graphite, and fullerene is coming, and in this it is, you can say, charcoal, lamp black, coal. These are the micro crystalline form or smaller crystalline form. One is your crystalline form, another is your microcrystalline structures. And allotropes of carbon are divided in two types. One, as we have already discussed, crystalline forms and microcrystalline, smaller crystalline forms. In this, charcoal, lamp black, and coal is coming on this category, and diamond, graphite, and fullerene is coming in this. Friends, this is all about a short introduction in the first lecture of this chapter, and in the more, if this allotropes and hydrocarbons, we will learn in the next chapter, next video. Is it right? Till then, bye bye. Thank you.